Once again, good evening and thanks for joining. Okay, good morning, good evening, or good afternoon, wherever you joined. Okay, take according to the greetings. No, I know everyone is being in the mood of tomorrow. Being tomorrow is our 1 year is ending and new year is starting. Okay, so I won't discuss more today also, but I will present some important slides which I prepared today. Okay, especially uh, for architecture only. I'm just making strong on architecture. Okay, I just added some more slides. Okay, to understand little easier. I will address on that slides more mostly. Okay, as I told you, being we are in the celebrations. Okay, I won't talk more on the subject today as well. Once we back. Okay, after New Year started. Okay, January 3rd onwards, the actual subject will start. Okay, and we'll go for more technical on not only PostgreSQL in the morning batches also. I'm going little slow only. Okay, so that's the one thing. I will address everything remaining things that are ending. Okay, don't disconnect. Okay. Now today, as part of in continuous for last session. Okay, whoever missed, just go and watch the last session. Okay, little interesting concept. Regarding today's session. Okay, what we are going to discuss almost same only, but I make little simplify to understand easily about how PostgreSQL engine is working in the background. Okay, so a same concept. If don't think that you are getting bored, but try to understand. I added some slides. Okay, uh, before I go into the slides. Okay, let's where is my let me bring see. For example, see a user. Okay, so who is going to perform a select statement? A simple, for example, select star from employee table. No, first he wants to read the data. Okay, he wants to read the data. What he will do? First, he will establish the connection. First, he will establish connection. That connection we are calling as a postmaster. Okay, or main process. Okay, once you establish the connection to the postmaster, once you establish the connection to the postmaster, this is very important. Okay, postmaster, once you establish the connection, then there will be background process will be created. Background process will be created for every request. So every user, it will create a background process. In the background, it will create a background process. So once you authenticate to the database, once you authenticate to the database, okay, DB. Once you authenticate to the database, first it will go to the shared buffers. Okay, this is very important. Okay, we are calling as a shared buffers. Shared buffers. Shared buffers. In the shared buffers, okay, is the main is nothing but like a kind of RAM. Okay, so like a kind of RAM. So here we are having shared memory. So in terms of understanding, let's make it as a shared memory. Okay, let make it as a shared memory. Okay, where it contains the shared buffers. Shared buffers is nothing but like a data cache in SQL. Okay, data cache. And we are having WAL buffers. WAL buffers. And unlike a log cache. Like a log cache. Assume user one, okay, user one perform one select statement. In it traditionally, okay, sorry, in traditionally, what it will do, first it need to establish the connectivity. Once it establishes the connectivity, you will get the process ID, PID. Here also, process ID will get it. Once you got the process ID, first it will go to the data cache. It will try to verify whether the data is available in the buffer cache or associate buffers or not. In a traditional also same thing. First it will go and verify whether data is available or not. So if data is available, okay, let's little zoom. Okay, if currently assume I am triggering first time, obviously there will be no data in the shared buffers. In the wall buffers also nothing because I'm triggering first time. Now you are having a data files. Data files. Don't think like a MDF, LDF kind of stuff. It's a files. Okay. It's a files where your actual data is storing. For example, your file ID is 2593. Okay, this is the file where it contains the data. Your employee table data will be available in this file. Now, what will happen? It will try to copy the file and store into the state buffer and sends the request to the user. Sends the request to the user. Next time, when you are running the same select statement, for example, user one, again running the same select statement, it no need to get the process ID. Okay, no need to authenticate because already authentication is done, process ID is done. Okay, now what will happen? It will come here and it will verify whether the whether the whether the blocks are available. Like a blocks, we are calling as a blocks. Block is nothing but page only. Don't get confused. Here block size is 8 KB, like a pages in terms of pages only. Okay, but not our SQL like stuff kind of thing. Don't compare with SQL. Like here we are calling as a okay blocks. Okay, shared buffer blocks. Each block size is 8 KB. When we go for practical, I will show you how to see that shared buffers, how to see that shared buffer size. Everything will go on talk on practical only. Don't get confused. Just think high level for theoretical purpose. Now your block size is 8 KB, like a 8 SQL also 8 KB pages. I'm not sure about Oracle, but 8 KB, like a page only. Now, next time when you run the same select statement, no need any process ID, no need any authentication because you already been authenticated. Now, directly it will go to the shared buffers and get the data if the data is available. If the data is available. In case if there is no data, in case in the middle there is a cleanup is happening or you done some modification, again it will go and get the data from the data file and place one copy and sends to the user. It's a traditional approach only. Up to this clear, everyone? No? Yes. Basic approach. Everyone clear? For select statement.
Yes, sir.
Yes.
Yes, sir.
Y-
Uh,
y-
just
Yes.
one question. Sorry.
Y-
That select statement, like every time it will be a same session ID, or I mean, that's what I'm not getting. Um,
See, there is a process ID. There is no concept called session ID like a SQL
oh,
gives.
sorry. Yeah,
It's a
sorry. Yeah,
process ID. Already
PAD.
you generated one PID. With the same
Mm-hmm.
PID only you are working. Okay? No,
Oh,
that's what.
okay.
Once we go for practical, I will show you clearly one by one so that you can understand. No,
Sure, sure.
don't go beyond. Just think, okay, what is happening? How the data movement is happening? Okay,
Yeah,
stick with that one.
okay.
I will show you everything practical. Okay, how to see that shade buffer, whether you are getting from the shade buffer or not. That will also will show you practically. Okay, slowly we'll go. It's not
Yeah,
like a hurry. Once we
sure.
once we start the product installing, okay, then you can understand. Okay. Now, for example, if you are performing any update, okay, if you are performing any update or insert or delete. So, for example, you are going to perform update, okay, update, update, insert, delete. Means you are doing some modification. If you are doing some modification, so again, what will happen? How the process? Again, you already know. Okay, first it will go to the shared buffers, whether there is a related pages are available, means blocks are available. Blocks are available. If there it contains the space, it will try to lights it will try to start modifying the data. It will try to start modifying the data. Either it can be update, it can be insert, it can be delete. It will start modifying the data in the shared buffers, and the same metadata update will be happen in the wall buffers, like the same, right? In SQL also, you remember all the changes will be happen in the data cache. Now The metadata is nothing but log records. Okay, whatever the changes you are going to do, we will call it as a technically log records, right? That log records information will be logged in the log cache, correct? Yes or no? Yes or no? Either it can be update, it can be insert, it can be delete. That information will be logged in the WAL buffer. Now, see, in SQL, you are going to protect, means there is a log writer which is writing the log cache to the LDF file, right? You remember everyone? Yes or no? There is a log writer, right? Log writer. Don't tell no. Everyone knows. Okay. Log writer, which is writing all the log records from buffer to LDF file. Like same here also, there is a concept called wall writer. Wall writer, which is writing all the metadata related to your modification to the wall, wall disk. Okay, wall disk. This technically we are calling as a wall segments. Segments. I hope you understood now. Wall writer, which is going to write into the disk from cache to disk it is writing. This we are calling as a LDF file. You can call it as like LDF file, log file, log file, log file. Now, you whatever changes you done, that is still in the shared buffers only, right? It is not yet moved to the MDF file. See, whatever the changes you are doing, parallel it is moving to the LD log file, so WAL file, because you need to protect in case of any disaster occur. You can recover the data with the help of WAL segments. You can recover with help of WAL segments. Now, what is happening now? The changes is still in the shared buffers. Still, it is not yet moved to the MDF file. Like sorry, don't call it as MDF file. Data files, data files. You can call it as a data files. The changes whatever you done, which is available in the shared buffers, is still not yet moved to the data files. Now, who will take care to move this one? As you already know, there is a concept called checkpoint. Okay, there is a concept called busy writer. Okay, busy writer, which is going to take and care to move whatever the changes you've been done, and it is in the available in the shared buffers, will move to the data files. So who is going to move? Either busy writer, either checkpoint. Either busy writer, either checkpoint will take responsibility to move whatever the changes you've been done from the shared buffer to data file, and make mark this as a, not make, sir, mark this as a clean page. Clean pages. Earlier, these are the dirty pages. Earlier, these are the dirty pages. Once your data is moved to the MDF file, this will mark like a clean page only. Got it? No? Yes? Everyone? Your busy writer, your checkpoint will take responsibility to move from the sheet buffers to data files. Your wall writer will take responsibility to write from the wall buffer to wall disk. Disk, disk. Okay, it will move into the disk. Okay. Now, when everyone understood about this concept, sir, almost you are good only. Okay, that is what is happening in the background, but you will get some doubt. What about the checkpoint interval time? All that we'll see, sir, slowly. Okay, once we start installing, we'll discuss all this stuff. High level, everyone clear? No? Yes?
Yes.
Yes. So there is a concept called wall archive. Wall archive. There is a concept called wall archive. Archive. You know about wall. You know about archiving, right? Like there is a concept called wall archiving. Wall archiving. So, what do you mean by wall archiving, sir? What do you mean by wall archiving? So, for example, by default, your wall buffer size will be 1 GB. Okay, assume by default, your wall buffer will be size will be one GB. Again, sir, you need to enable at the database level wall archiving. You need to enable wall archiving. Otherwise, There is no concept called wall archiving. There is no concept called wall archiving until unless you should enable. For example, you enable wall archiving. Okay, now how it is working in the background? Okay, how it is working in the background means your wall buffer size is 1 GB. Now, for example, you started modifying the data like update, insert, delete, whatever. You just started modifying the data. For example, okay, uh, one file. Okay, let's move a little higher. Okay, for example, where is small wall. Okay, buffer size is this one, which contains 1 GB. Okay, now you are doing some modification. For example, this is the file of 25 MB. This is the file of, okay, there is one file like contains 16 MB. Okay, there is one file which contains 25, 250 MB. Okay, how many files it will fit in this 1 GB? Based on what is the file size, right? Whatever the changes you are doing, how much massive change you are doing, based on that only the size will vary. So, for example, assume if 1 GB got full, 1 GB got full. What is the hierarchy then? Now, see if you enable wall archive, okay, archive. Now, what it will do, right? Before overwriting this data, before overwriting this data, see, once this 1 GB got full, automatically it will start overwriting from the first file. Means your data will be overwrite from the first file. Before it overwrite the data from the first file, what it will do? It will copy this to the archive file. This 25 MB will copy to the archive file. This will copy to the archive file. This will copy to the archive file. Then it will start overwriting the data so that your wall buffer can be reused. Of course, it will be reused, but even before it reusing, I want to protect the data additionally. Then I can also archive. But if it should work, if this algorithm need to be work, you need to enable wall archiving. Otherwise, there is no concept, sir. Once this 1 GB got full, then it will start overwriting the from the first file. Okay, everyone? No? Yes? What is wall archiving?
Yes, sir. One question like this wall archive will be in their memory only, right?
Disk, sir. Disk. This
This
is the
oh,
disk. Yeah, disk. In the memory means then what is the purpose again? We wanted to move into the disk, okay? And before it is overwriting, we want to make it as an archive for safe side.
okay.
So, this is in wall buffer or in wall files. When 1 GB wall file will full, it will move to wall archive.
If you enable, it will go to the wall archive before it overwriting the data in the wall
Yeah,
buffers.
from where to wall archive? Like wall buffer to wall archive or wall file to wall archive?
From wall buffer to wall archive, it will move.
Okay. So
Point
wall
in time
archive
recovery
is
required
level.
wall archive enable is yes, point in time. For point in time recovery only, we are going to concept called wall.
It's this wall archive in disk level, not memory level.
Oh, this one.
Wall archive.
Yeah, that's what, sir, I'm saying. Before it overwrite the data, it will move the data to the wall archive.
Okay.
So this wall archive is a physical file or in memory? It should be in physical file, correct?
Yeah.
Sir, it's overwriting means the existing one, it auto deleted or how, sir?
Overwrite means it will use the space, right? See, after this is the default behaviors, okay? The problem where is I don't know about how the Oracle will work. Is there any concept called wall for
Uh,
Oracle?
yeah, yeah. So, I mean, it is
Yes,
just
yes.
same. I believe it is a log archive file. So, what I'm
Yeah.
understanding, it is exactly same. Just the, the naming convention they have changed, but concept wise, Easy to say.
Good, good. Okay, yeah. Is it clear, everyone, about wall buffer, shade buffers, wall archive? No? Yes.
Just brief about it, sir, for 1 minute.
It's a little bit confusing for me.
So,
Oh,
so
still you are
Subbu,
getting. No, no, no. Yeah, I need to clarify all the doubts. What confusions are? Yes, someone is asking.
yeah, Subbu. So, what is the use of wall segment, Subbu, here?
See, wall segments are nothing but it is moving to the disk your data. See, currently it is in the buffer, right? See, currently it is in the buffer. Okay, if something happen, your buffer can crash, right? Everything gone. Okay, now you need to move to the disk, right? How you are moving to data to the disk? Okay, in the form of wall segments. In the disk we are calling as a wall segments. In the buffer we are calling as a wall. It's a cache. This is a cache. This is the disk. Like a log file, sir. Simple for your understanding of this. It's
Okay,
a log
okay,
kind of log file.
okay, Subbu.
Yeah.
Subbu, one doubt. Subbu,
Yes.
we have also wall files. So why we need extra wall archive?
Sir, if you want, you enable. Otherwise, you no need, sir. There is no focus that we
Yeah,
mustn't should enable.
for
That's
which
what
case,
I'm
for which case we enable?
to protect our data. See, finally, you need to protect our data, correct? Yes or no?
Yeah,
Agree, not agree?
we have also, yeah, we have also wall files also, no? So it
Okay.
will move to
Let me
that
ask a
wall buffer to
question.
wall file.
Let me ask a question. You are having your documents. How many copies you are maintaining, sir? How many
Two, three
copies you are
copies.
maintaining? Why? You are already having
Uh,
original document, right? Why you are maintaining all that copies?
to protect extra security.
That's what, sir. Here also, I wanted to protect my data.
Okay,
Okay.
fine.
If
It
I
is not
want to go
mandatory, it is
on,
optional.
yeah, that's uh, what I wanted to convey is if you enable archiving, then only this activity will come. Otherwise, there is no concept called wall archiving processor. You got it,
Subbu,
Bhushan?
yeah,
Yeah.
yeah. If we enable this one, is there any performance impact?
No, sir. No, nothing. Don't go performance all the stuff, sir. Okay. Let's think from the starting place. Okay. I We are starting in the journey. Okay. Let's don't go for high level right away. Just think how it is working, how these are working. Okay. We don't want much. Let's see practical. Then only we'll conclude all the stuff. I hope you are getting my point, everyone. So let's go little slowly, sir. Okay, we don't want to think about performance, all the stuff first. Let's start how this functionality because you are learning a new concept. Basically, we are learning a new concept. First, we need to understand the functionality. Later on, we'll go slowly. That's what I told to everyone. So whoever joining in the first batch definitely will be in the second batch as well. So whatever I can enhancing. So in terms of to simplify the terminologies, okay, I maximum I can try in the current batch only, but still in case anything still pending, definitely I will cover in the next batch as well. So bear with me some more time. Now this is first thing I wanted to talk today. I think Adam, you were having sorry, you told that you were having some confused. What is the confusion? Very simple. There is nothing, Adam. You no need to think. Okay, it's think like a SQL only. Shade buffer is nothing but data cache. Wall buffer is nothing but log cache. So whatever changes you are going to do, okay, physically the files are available here. Logically the metadata is available. That metadata is going to the LDF file. This finally data is going to the data files. So who is going to move? Either busy writer checkpoint is going to taken care. Who is going to move from the wall buffer to here? Wall writer is going to taken care. Here we are calling as a block. Each block size is 8 KB, like a page only, sir. Getting my point? Once you establish the connection, there will be background process, which is you will get the process ID. Via that process ID, you will do whatever you want to going to perform. Okay, authentication is little different, sir. Don't compare with the SQL. Okay, don't compare with the Oracle. I'm not sure about Oracle, but don't compare with any. PostgreSQL authentication is little different. I will show you everything practically, the connectivity, so that you can understand. Okay. Still, Adam, any doubt in this part? No? Yes?
Sorry, Sibu, I was talking on mute. So that part I get,
Hmm.
where up to the WAL buffer, that I get. But when you introduce the WAL archive now, I was just trying to actually look into what I'm
This
familiar
is
with.
something new for SQL, Adam. Okay. This is something new for SQL DBAs. Okay. But Oracle, they're already aware of this concept. Okay. Especially for SQL, this is new concept, wall archiving. See, what they are doing means, okay, for example, uh, assume your wall buffer size is 1 GB. Okay. Now, once this is filled, it will start overwriting the data. Before it overwrite the data, it will make a copy. Okay. Make a copy to the wall archiving if you enable. Otherwise, it will start overwriting from the first file onwards. It is reusing. Wall buffer is reusing. But before reusing, if you want to make a copy, yeah, you can go and copy by enabling the wall archiving. Otherwise, it will reuse. Your log file is also same, right? Your log file will be reuse, like here also reusing. But they introduced a concept called wall archiving. That's it. Apart from nothing else there.
Oh, okay. Now, all right. Now I understand. So my question then, Sibu, is: so if then it's going to be overriding, what happens to the
Overriding,
data?
yes. Yes.
Is
Is
the
here it
data
is
gonna
override.
still? So if it overrides, it means the data is gone, or the data still
Gone.
is available, since
Data gone,
it's
right? If
writing
you override
to.
means gone. It's gone.
Okay, so then we can conclude to say that the whole archive is very much important to be enabled, because
But no
we still
worries.
need the.
Already your data is copied in the wall segments. See, forget about
Oh,
this is
okay.
happening in
All
the
right.
buffer.
Okay.
Or this is
Okay.
happening in the buffer. Your data is in the protecting in the log file. But even though if you wanted to protect more in terms of concurrency, in terms of protection, then definitely you can go for wall archive.
Okay. So best practice is to enable it, or it all
It
depends.
depends, sir. It depends. I can't say. Okay. It depends.
Okay. Thanks, Bo. I think I understand it. Thank you very much.
Yeah.
Sir,
Like,
if enable this feature, it impacts any performance issue.
sorry, ma'am. Performance issue.
Yes, sir.
Nothing. Nothing. Okay. I can say that. Okay. Now we discussed about the shared buffers, we discussed about the wall buffers, we discussed about the data file, we discussed about the wall segments,
Sir, I have
busy
one
writer.
small doubt, sir.
Yes, Nagaraj.
Whenever checkpointer and BG writer occurs, okay, whatever the data is not yet moved to the shared buffer, that data will be moved with the help of BG writer and checkpointer, right?
Yes.
Okay. And what are the data which are available in the wall buffer, sir? That also moved through the checkpointer only.
Oh yeah. Oh,
Wall buffer
okay.
to wall
Oh,
segments.
today I not highlighted that one. Last session I highlighted, right. Whatever the data which is not yet moved, it will go here. Whenever checkpoint run, not busy writer. Whenever busy writer checkpoint run, if the data still not yet moved to the wall buffer to wall segment, it will move and it will start. Okay, like a kind of upline. Okay, like a kind of note. Yes, it will move.
Okay, wall buffer to wall segments,
Yes,
wall writer will move.
yes.
Then again, wall segments to data files, it will move, right?
The mainly focus is here, sir. Okay, this wall writer is going to taken care. In case if there is a gap between wall writer to wall writer and there is a checkpoint is triggered, that time, yes, your answer is right. Not see, even you know in the SQL server there is a concept called checkpoint and lazy writer.
Yes, sir.
Whenever lazy writer triggers, not only moving, not only flushing, it will also move the data, right?
Yes, sir.
Okay. While it is moving, not only data cache, log cache also it will move.
Yes, sir.
Okay. Here also same concept, nothing. But the terminals are little changing. Okay. Almost the concept is same. We are calling as a pages. Here we are calling as a blocks. Okay. You will call it as objects. Here you will call it as a relational. Okay. You will call it as a rows. Here you will call it tuples.
So here
Okay.
wall buffer to data files, only checkpointer will take the responsibility, not BG writer, right?
Shade buffer to data file is responsibility either busy writer or checkpoint, sir. Okay.
Okay.
Wall buffer to wall segments, wall writer. That's it.
Okay. Okay.
And yesterday, last session, we also discussed about the log writer. Log writer. What does it mean log writer? Any errors related, okay, it will write in the error log files. Your log writer will taken care to write the error related information in the error log files. Until unless you enable archive, it will move to the archive. Otherwise, though it won't, there is no concept called archive walls. So this is what we discussed yesterday, last session. Busy writer, wall writer, okay, and log writer. We haven't discussed about the checkpoint. We haven't discussed about auto vacuum, archiver, okay, and archive, okay. There is a concept called archiver, which is going to take care. If you enable this archive wall, okay, then archiver will take and move to the archive files, okay. Stat collector will discuss later. Checkpoint will discuss later. Auto vacuum is very important. Very important auto vacuum. For SQL people, this is completely new concept. For Oracle people, easily they can understand. Okay, we'll talk more on the auto vacuum as well. If I go to the next slide, okay, what I want to, yeah, see. What I want. See. Okay, let's see, sir. Now, I just added some flavors here. Okay, see, when the front end. So if you are connecting from the okay, command line called PSQL, or if you are using any third party tools, or you are using any PC admin for. If you are trying to authenticate, okay, first it will connect to the Postgres server, okay, server, nothing but like an instance. So once it authenticate, okay, now it will generate one process, okay, PID, process ID. Once it got process ID, directly it will go to the shade buffer based on your request, whatever your request. Like see in the shade buffers, like connection manager is very important. So once you got authenticate everything, like in a traditional also, in all the database management system, okay. First is syntax checks. Okay, in the parser will do the syntax checks, semantic checks, everything it will do. Parser will check the syntax checks, will do the semantic checks. Okay, and it will try to rewriter. Right? See, there is a concept called rewriter. What do you mean by rewriter? Means what exactly the rewriter is doing. So, for example, no, there is a concept called syntax. There is a concept called semantic, and there is a concept called query tree. Here also same concept. Okay, parser will do syntax checks, semantic checks, and prepare the query tree. Okay, what is that rewriter is doing in terms of rewriter? There is a concept called rewriter means. So, for example, in your query, there is a view. You are calling a view. So for example, you are writing one select statement, select, okay, start from, okay, view, like a view. It's not a table, it's a view. Now this rewriter, what it will do, whatever the query, whatever the view you are going to call in the select statement, right? Now it need to point to the base table, right? It need to point to the base table, right? That pointing to the base table will taken care by the rewriters. I hope you are getting my point. So it will check the syntax checks, it will check the semantic checks, it will prepare the query tree, okay. Now it will also rewriter. There is a concept called rewriter in the PostgreSQL. What exactly it is doing, right? In case whatever the statement you are going to run, whatever the query you are going to run, if that query contains any views, materialized views, okay, it need to point to the base table, right? Now that will be taken care in the rewriters. That will be taken care in the rewriters to pointing this view to the base data files. Base data files, base table data files. It need to point because it's don't compare with SQL Server. Okay, don't compare with SQL Server. Your table is storing in the form of files. Now this is view is nothing but a subset of the table, right? Okay. Now don't call it here as a table, sir. Here you should call it as a relational. Okay. Now this relational will point to the base relational table. This relational will point to the base relational table. Who is going to take care? This rewriter will take care. So it will check the syntax checks, it will check the semantic checks, it will try to prepare the query tree, and it will also rewrite the query based on your request. It means it will point to the views, will point to the base data files. Once it is done, then it will go for planner. So here also there is a concept called execution plan. Here also there is a concept called execution plan based on the indexes, based on the index we created, right? Index we created, based on the index created, whether it need to go for SAN, it need to go for seek, okay? That will be taken care in the planner. Not don't compare with the SQL, sir. Again, a planner will try to prepare the execution plan based on the what sort of tables you are going to do, what sort of indexes are available. Based on that, it will try to prepare the plan. Once the plan is ready, and it will choose the best plan. Once the plan is ready, it will choose the best plan and go to the executor. Then your executor will start executing the data. Executor will start executing the data, but there is no concept called data in the query processor. Okay, where the data is available in the storage, like a data files, like a WAL files. Okay, now it will go to the data files to get the data and saved in the shared memory. Is it traditional only? Is it clear, everyone? What is happening? How SQL is also working, like almost this is also working same. But something here and there, the changes has been occurred. Otherwise, almost same only. There also in SQL, in Oracle, any technologies, it is checking the syntaxes, semantics, preparing the query tree, okay, preparing the plan based on what sort of indexes are available and choose the best plan and go to the executor. Executor will start executing the query, but there is no data. It will go to the data file and get the data, place one copy in the shared memory and sends to the user. Got it, everyone? No? Yes?
Yes, Subbu.
So what is semantic checks?
Semantics. Oh, this one. Oh, you need whatever the objects you are specifying. So, for example, select star from employee. If this table is available or not. If, for example, you mention here employee ID, employee name, employee server, the columns are available. It will verify whether this data is available, whether these objects are available, columns are available, whatever the data, whatever the parameter you passed in the predicates, whatever the data type is matching, all it will verify in the semantic checks. Now, what is happening in the shared memory? Okay, see, uh, why not mention a client users? Okay, n number of clients can access her. Okay, like a client one, client two, client three, and n number of process. Two. Sorry, I'm still working on this PPTs. Okay, maybe I need to update here. Almost three and three both are same one. Sorry, sir, I will update. Okay, now see if n number of users are trying to connect. Okay, n number of users are trying to connect, and each one will go to the. This is our shared buffer. Okay, this is our shared buffer. In the shared buffers, okay, what it before shared buffers, assume there is no concept called buffer. What it will do, all the process will directly go and try to read the data files. Agree, not agree? Yes or no? All the background process will go and try to read the data files. You know where the data files are hosted. Your data files are hosted in the disk. Okay, definitely it will impact the performance because these are the physical IO. Physical IO, but I don't want physical IO. I want logical IO. Then what I need to do? Then your database engine try to start coming with the concept called shared buffers. Where is it? Sorry. Okay. Now there is a concept called shared buffers. Now what exactly you will do? it will try to find any data is available in the shared buffers or not. So in case if shared buffers are not available, it will try to get the data from the physical and it will try to place one copy in the shared buffers. Okay, and you have restricted the shared buffers as well. Okay, you can restrict the shared buffers as well. For example, there is only one concept in the shared buffers. Okay, for example, in the PostgreSQL, only there is a concept called shared buffers. Means so no sir, there is one more concept. See, for example, if you are trying to access the data, what it will do? Okay, it will try to copy the from the physical and it will place it in the shared buffers. And from the shared buffers, user can access. Shared buffers are logical IO because this is in the memory. This is in the physical disk. So always memories will give the best performance when you compare with the physical. When you compare with the physical, when you compare with the disk, memory will give the best performance. Now, not only this shared buffers are what Postgres engine is doing. Okay, what Postgres engine is doing. There is one more concept called OS cache. Okay, what exactly it will do is when you are performing any operations, first it will try to verify is there any data is available in the shared buffer or not. In case if data is available, it will try to get the data and sends to the client. In case if data is not available, it will also do one more check that is nothing but OS cache. It will also do one more thing that is nothing but OS cache. OS cache. So it will verify whether whatever the data you are requesting, whether it is available in the OS cache or not. In case if data is available in the OS cache, then it will send the data to the user. So to avoid the physical IO, what PostgreSQL engine is doing, first it will try to verify whether data is available in the shared buffer. In case if it is available, it will send to the user. If not, directly it is not going to the data files which is available in the disk. Now it is doing one more check that is nothing but OS cache, whether any data is available in the OS cache. Okay, then it will send to the user. Okay, so that it will avoid to perform the physical IO. It will try to avoid to perform the physical IO. In case your data is not available in the shared buffer, your data is not available in the voice cache, then finally your data gets from the physical only. It will get the data from the disk and it will place one copy in the shared buffers and it will send data to the client. Got it? No. Yes.
So this OS cache is related to specific operating system or for
No,
all
OS.
operating system it will do?
OS is nothing but operating system only, right?
Like for Windows operating system, default OS cache, Linux for default OS cache.
Basically, PostgreSQL, there is no concept. Mostly we won't install in the Windows server. We'll go for Linux only. Okay. Think from the
Okay.
Linux point of view. Mostly we won't install PostgreSQL in the Windows. But being we are in the learning phase, I will try to install first in the Windows. Then I will go for Linux only. More I will discuss in the
Yeah.
Linux. Yeah.
Yeah. So in case of Windows, this architecture will be also same.
Come on, sir. This is the engine. Don't think like a Windows. Don't think it's a Linux. Okay.
No, no.
It's the engine.
I'm asking
How
about
that
this
engine
OS
is working.
cache.
That's what OS cache means. OS cache only, right? What was your doubt?
Like I'm thinking that this OS cache is specific to specific for specific operating system. Like for Windows OS, it will be different, and Linux for different.
But it's not like Windows. It's not Linux, sir. Your engine, anywhere I mention that this is a Windows architecture, this is Linux architecture. I am explaining about
Oh,
the PostgreSQL architecture. That's it. Okay.
okay.
That's what the SQL people you will get lots of confused. Okay, because we haven't experienced that how Postgres engine is working. But that's what, sir. Don't think more. Let's first install one Postgres engine, then PostgreSQL engine, then you can understand easily, okay, what sort of data, way, how that data is stored in one system. Yeah. Nagaraju, I think you were asking a question.
No, sir, no, sir. Sorry, it's unmuted. Right, yeah.
Okay. Yeah. Yeah. Girish. Yeah.
Yeah. Yeah, so what I understand, this OS cache, it is not part of the RAM, right? It is
See,
altogether
basically,
a different entity.
let's understand. Okay, let's understand. Okay, how I can present you. For example, this is my laptop, right? Okay, this is my laptop, and I am having 250 GB of, for example, 512 GB of hard disk. Okay, now 512 I am going to segregate into C drive, segregate into D drive. Correct? Yes or no? Yes, no.
Yes, yeah.
Rest of thing, whatever you are going to keep, that will be part of C drive only. Correct? So you, whatever you are keeping in the documents, whatever you are keeping in the downloads, whatever somewhere you are going to keep, those are a part of in the C drive only in the back end. Correct? Knowingly, unknowingly, is storing in the C drive only. See, it is consuming C drive space, right? But something, whatever you are keeping in the desktop, okay. See, PostgreSQL, don't think like a SQL or it like MDF file, LDF file. It's something. I'm not sure about being you know about Oracle, how the files are storing, how your tables are storing. I don't know about how the Oracle data table will store. Okay, here in the PostgreSQL, it will store in the form of files. Okay, these files. So if you open, okay, I told you, right? This is one table. This is one table. This is one table. This is will be in the form of files. Okay, this is one table. You are seeing like you are thinking that okay, this is one a file and it is like a number. Okay, no, sir, it is a table actually. It's a table in PostgreSQL. If this in the cache, OS cache, it will try to retrieve the data from the OS cache. If that's what there is one more layer of scanning. What it is doing, it is try to scan anything in the OS cache. If anything, it will try to get. If not, definitely it will go for shared buffers. It will go for disk only, sir. Getting, not getting everyone. So how in SQL Server there is a concept called MDF. In the MDF file, you are creating the tables. You can't see, only will see one file. But in the PostgreSQL, no, it's one table. This is one table. This is one table. These are all tables, sir, basically. In this only there is a data. In this only there is a data. So that's the reason we are calling it a data files. Don't think it is a MDF file. Data files. These are all data files. That's what. Once we start building PostgreSQL installation, you can understand easily, sir. Bear with me some more time, okay? That's the reason I am not completing architecture by today itself. I am slowly making you to comfortable, feel too comfortable. That's the reason I am telling don't go for performance level, that level, this level, okay? Firstly, you don't know how this engine is working. Then why we are thinking, why we need to think for performance. Got you, everyone? No? Yes?
Yes, Subbu.
Okay. Okay. To simplify more, okay? See, for example, if you are performing a select statement, for example, sir. Okay, not only select statement, even you are performing reads. Okay, you are performing reads, you are performing writes. What is the background process will do? First, it will go to the shared buffers and it will try to verify if data is found or not. If yes, it will send the data to the user. Okay, if no, it will go to the OS cache as well. It will verify anything is available in the cache. Anything is available in the cache. Then it will send here. If not, finally it will go to the your physical location only. It will try to read the data. It will try to read the data physically. It will validate physically to get the data from the physically. Okay. Oh, sorry. I lost everything. Sorry. Okay, fine, everyone.
Yeah.
Okay. Now, sir. Okay. Some of the terminologies are very important. Okay. As a PostgreSQL, we are starting our journey, right? We need to understand some uh, terminologies. Very important. Okay. Sir, here we are creating a cluster. Okay. I told you, right? We are going to create a cluster. This is one cluster. This is one cluster. Okay. A cluster. Once you install, okay, once you install PostgreSQL engine, okay, first thing you need to do is you need to create a cluster. You need to create a cluster. Okay. This is technically speaking. Here, don't compare with SQL cluster. Okay. Don't compare with SQL cluster. Don't compare with any. If there is a concept called cluster in Oracle, don't compare. Sorry. Okay. I am just creating a folder. Okay. I can create a cluster here. I can create a cluster here. Means this is one instance. This is one more instance. I can just create a folder name called okay, easy blue. Okay, and I can build the cluster here. Very simple. If you run one command, it will create a cluster for us. This is one instance. This is one instance, which is running in the same, which is running in the same operating system. You can create one more instance. You can create one more instance. You can create unlimited. Okay, not unlimited, sir. There is a concept called port. Okay, especially there is a concept called ports. Okay, maximum you 64,372 some ports. There is a limitation, right? Minimum you need to go for 1024. Maximum you can go for 64,000 something, right? So can I create unlimited folders like this? Can I create unlimited clusters like this? No, because each cluster is you can differentiate with the port number. Very important is port. Here port is placing a major role. Here port is placing a major role. This cluster I will run with a different port number. This cluster I will run with a different folder port number. I can create one more cluster. Okay, and I can make this run to different port number. Like this you can build different n number of clusters, but each cluster need to run with the unique port number. Each cluster need to run with the unique port number. Is it clear? First, once you install the Postgres engine, first thing you need to do is that you need to start the cluster. It means you need to initiate the cluster. Once you initiate the cluster, you need to start the cluster. Then only you can authenticate to the PostgreSQL server. Otherwise, you can't authenticate. Either you can authenticate using pSQL or you can try to authenticate using pgadmin. First, you need to create a cluster. A cluster is nothing but collection of databases and many more. Many more. I told you, right?
Can we call it collection of instances?
No. Collection of instances is something different, right? This is one instance. Like technically speaking, this is one instance. What do you mean by collection of? No. A cluster is nothing but collection of databases. Okay. Here you will create a databases. All it will store in the form of here only. This is one database. If you create one more, it will create one database. That database, it will contains the tables. These are all the tables. This is your database. This is your database. These are all the tables.
Okay.
So cluster is nothing but collection of databases. And database is nothing but collection of objects like tables, views, materialized views, indexes, all this stuff. And you will also create the schemas. In traditional, you know how to create the schema. Here also you will create the schemas. Okay, tables or indexes, technically you will call it as a relation. Okay, we won't call like a tables, we won't call like indexes, we'll call it as a relation. Okay, relation. And rows will call it tuples. Okay, like column in the table will call as attributes. And every instance, this is very important, every instance it must and should run with the unique port number. Otherwise, you can't start. So for example, I created multiple clusters here. So this is one cluster, this is one cluster, this is one cluster. By mistakenly, you forget to change the port number. Both are running with the same port number. Only either this one or this one only run. Who is running the first time? who is going to start the cluster first, who is going to start the cluster first, that instance will run. Rest instance will be in the stopper set because only one port number is compatible for one. Another server you can go for different port, same port number. For example, here you are going for 1459. Can I go for 1459 port number for different instance, different server? Of course, yes, sir. Yes. Okay. Of course, yes. But within the same server, can I use the same port number for multiple clusters? No. No. This is one very important point you need to remember. Okay? Not okay, everyone?
Yes. Yes.
So here, first we will create the cluster. Once you complete the installation, this is my mouse. Come on here. Okay, yeah, fine, fine. So once we create the, once we okay, install the PostgreSQL, first thing you need to do is you need to create a cluster. You need to create a cluster. So for example, if I go to the program files, if I go to the PostgreSQL, okay, so here also by default there is a cluster is built. Okay, yeah, that's it, sir. So on Friday we are going to build first how to install. We are going to start learning how to install, okay, PostgreSQL, and how to create a cluster, how to start the cluster, how to connect the cluster. This is what next agenda, sir. Okay. Then I will come back to the architecture only. Sir, first we want to be strong on architecture because this is something different. Okay. So first 15 days, as I told you, right? First 2 weeks we will completely stick with the Windows operating system. Next 3 to 4 weeks we'll stick with the Linux operating system. More on the Linux only, sir. But to make you little comfortable, I first 1 week or first 10 days, I don't go for 1 week also. First 10 days, I will go with the Windows operating system. Then finally, I will go with the Linux operating system for more. Because in real world, you will see the Linux operating systems. Yeah, that's it. For today's session, don't disconnect. Okay, stay back. Okay, let me stop the recording, sir. Any question before I stop the recording? So this is the cluster is not exactly high availability option. No, Annabelle, wrong. Okay, don't think SQL cluster. Okay, no, it's not a SQL cluster, sir. No, nothing. Cluster is nothing but collection of databases. Okay, don't think SQL cluster. It's not like. Any questions before I stop the recording? Anyone?
Yeah, Subbu, what is the
Yes.
difference between cluster and instance?
Cluster and
Instance.
oh, you can call, see. Basically, we are a SQL. I don't know about whether you got SQL. Being we are a SQL engineers, we will call it as an instance. Most familiarized. That's the reason I am just calling as an instance, sir. Okay, technically, like it's a one server. Cluster is a one server. On top of the cluster only, you are going to build the databases. Okay.
Okay.
No worries. Once we perform one installation, then you will become automatically strong. Okay. How it is working functionality. We wanted to understand the functionality first. Yes, Nagaraj, you are asking question.
Yes, sir. Sorry for that.
Hey, no. You need to ask any number of questions, everyone. Okay, we need to clarify. If I don't know,
Actually,
I can go and I can research. I can get back to you. Other, if you're not asking, no.
okay.
Yeah,
Actually, if there are multiple like database clusters you are installed, by default the first one is 5432 port number, and the remaining will be how it will be allocated.
you need to change the port number in the PostgreSQL.config files.
We
Okay.
need to change, right?
Now we need to change. We are a DBS, right?
Any number we need to give or any particular sequence or like that.
See, we'll follow one hierarchy. It's not like a randomly we'll go. But here we are going for randomly, but in real world, definitely you will follow one unique port numbers. Okay.
For suppose one is 5432, remaining 5434, like we can give.
Yes.
Okay, okay, sir. Thank you.
Good. Any other questions? Aswini, Adam, Malti, Girish, Gautam, no. Yes, Manju, Sampath, Wilson. Wilson is so silent today.
Yeah, I'm good. I'm good.
Okay. Wilson is so silent. Vijay.
I think for me, Sbu, it was just on that architecture, but I think I'm answered. Yeah, I think the rest can fall in place as we go.
Okay. Yeah. Okay. Let's stop the recording.